Hello world, this is Christu and welcome to my C and C++ mega tutorial. I completed CS50X and I received 100% for my C problem sets. So I decided to make a long mega tutorial with C and C++ to learn the fundamentals of programming and also explore what the differences is between C and C++, so that you have some idea. For this video I will be using CS50 Sandbox. You can just Google CS50 Sandbox, link will also be in the description, and then you can test it out. So here we have a simple program that, given the length and width of a rectangle, this C++ program computes and outputs a perimeter and area of the rectangle. Now here on the side you will see three files. The one file is actually just an compiled program, so I'm just going to delete that for a moment so that it won't confuse you. So we have two files. We have main.c++ and main2.c. Main.cpp has some code inside of it, and main2.c has similar code, but we have some differences above. So below we have a terminal window. Now you may be familiar with a terminal window if you are a familiar programmer. Basically, we are going to use this terminal to compile and run all of our programs. And if you are using a Linux or maybe a Mac machine, you can also follow along and using this terminal, but you may install some additional software to get it working. So I recommend using CS50 Sandbox to learn new programming languages. That is what I will be using for this tutorial. So let's go ahead. Okay, now let's look at this program. On line 6 it says #include IOStream. What is IOStream and what does this #include? #include is like going to the internet or somewhere on your computer and looking for a library. This library you are going to use throughout your program. In this case we are using IOStream. IOStream stands for input-output stream. So where do we use this IOStream? If we look in this program, you may see cout. Cout means output to the terminal window. So if we run this program, this will be outputted to the screen within this quotation marks. So let's test it out and see if that is the case. So in the terminal window, all that we are going to do is we're going to say make main, and if we run that, you may see this file again that I talked about. This is a compiled program. The process of running programs on C and C++ is you compile the program, then you run it from your terminal window as well. So you compile using make main, and there is other ways to compile your software as well. You can use G++ with some sort of command line options. You can Google how to compile C and how to compile C++ programs using G++, and you will see a tutorial how to compile it. For the sake of this tutorial, we are not going to worry about the specifics of how we compile this program on an operating system like a Linux or a Mac. We are instead focusing on learning two programming languages, C++ and C. So we compiled this program and we got a main file. How do we run this? If we click on it, it says file contains binary data and cannot be displayed. Well, that is because when you compile a program, it gives a bunch of ones and zeros inside of this file, which means that it's a binary file, which contains binary data, which contains the information on how to run this program, basically. So how do we run this? If we go to the terminal and we say ./main, it will run. So we can see that it outputted this to the terminal. Program to compute and output the perimeter and area of a rectangle. And that's exactly what the program does. It says given the length and width of a rectangle, the C++ program computes and outputs a perimeter and area of the rectangle. And here we can see using namespace std. Well, that's just really important regarding cout statements, outputting information to the screen as well. Usually you will type these two lines together when making C++ code in order to output things to the screen or input things to the screen. So we can see a lot of things happening here, but it's not really a lot. If you're an experienced programmer, you may feel familiar with this. You have variables in C++. This is a double, which means it stores 2 decimal numbers, basically. Like, let's say 52.93. That's a double that will be stored. And if we look at other data types, you get ints, which basically is just whole numbers. And notice in C++, when you declare a variable, you always end it with a semicolon. The same goes with C. If you go to our C program, you will see it ends with a semicolon. And if we look at the C program, you may notice that this program is yet not completed. That is because we are going to complete it for you while we are doing this. But you can see that I already made some differences in the C program. I said #include stdio.h. That is like the include IO stream and using namespace std version of C. You only type this into C and then you can suddenly output things to the screen, which is kind of nice. So we declared 4 variables here of length, width, area and perimeter. Then we outputted program to compute and output the perimeter and area of a rectangle. And notice this syntax here. There's 2 arrows. That is just to basically add things to the cout. I mean, here we say program to compute and output the parameter and then if you look at here in the terminal, it continues area of a rectangle. So it continues this output statement basically. So you can output multiple things just by using these 2 arrows in C++. And then at the end we see end L, which just stands for end line. And you can see that at the end of this line, it just goes to the next line. And if you are familiar with C, end line is just \n. And maybe you can also do this in C++. Let's test it out. So you say \n, semicolon. Then we just run this program again. I mean, compile it and then run it. So we say make main and ./. And you can see the program compiles perfectly. That's because \n is an escape character for the new line character. That just means that when the compiler sees \n, it just automatically goes to the new line, which is kind of nice. So further we say length equals 6, width equals 4, perimeter equals 2 times the length plus width, and you can notice it's in brackets. That's because in programming languages, when you multiply multiple times, like let's say you say a bunch of mathematics here. Let's say you say perimeter equals 2 times 5 divided by 5 plus 60, and now we have just made a mess of everything, because what exactly is going to be the output now? Because we say 2 divided by 5, then it divides by 5, then it plus with 60. So what exactly will the output be now? So let's compile this program again. And you can press Ctrl L to clear the terminal window. So now we run this program and we see perimeter equals 62. So if we just get a calculator out and we type in this mathematics, we say 2 times 5, sorry, I already messed up. Okay, so we say 2 times 5 divided by 5 plus 60, and we get 62. So with other words, we said 2 times 5, which is 10. 10 divided by 5 gives you 2, plus 60, which gives you 62. Now you might think in certain circumstances you want certain mathematics to override others. Like let's say you want 5 divided by 5 to execute first, so you will put that in parentheses. So now we will see 2 times 1 plus 60, which will also give you 62. And at the end of our C++ program, we will see return 0. That's just something that you need to do at the end of your program. And that's something I also didn't really talk about, is this int main void. Int main void is just a specification to C++ and also C. You will see both of them is actually the same. It's just a specification to say this is the program that needs to run when I run my program and when I compile my program. That's just simple. And int main void is just how it's declared. You can Google on how it works. We will later cover it. Basically, int main void is just a function, and then we start and end the function with this curly braces. That's all that you really need to know at this moment. So our challenge now will be to convert the C++ program into a C program. And you can already see I started a bit before I started this video, just by copy and pasting, and also just changing our libraries to #include stdio.h. So now the big challenge will be to convert this program to a C program. So first, you can see int main void, that's correct. You can also write it without the void in C++ and maybe just in C. You can test that out. We can also test that out maybe. Okay, so without the void we're going to run this program. So now we want to change the cout statement here. So this output statement right here we're going to change to a C version of this. How we do this is we just say print. And if you ever done CS50, you can also just say #include CS50. I think it's maybe .h. Yes, it's just like this. So now we have this print statement. What we can do in this print statement is we can just put this double quotation marks and then just cut this here, space, and cut this, and we should see some results. If we just want to test out this segment of the program up into here, we can do something interesting called commenting. I would recommend doing commenting if you write big programs and you just want to test out certain segments of the program. So what we will do is we make just 2 slashes like this, and that is a comment. This will comment out this line, and you see the color change because this no longer will be interpreted by our compiler. And we can do the same here. And then if this gets tedious because you just don't want to type this out the entire day, there's also this other way to make comments, and that is /* and now you can see it commented out everything, and also this important part of our program which indicates the end of our main function, and that's not right. So at the end of this last line we just say a // and that will comment that out as well. So now we can just test out the necessary program. So we say make main2 because I changed the name so that the compiler knows which program to look at, and it says, did you mean printf? And it also looked for a semicolon because I didn't make a semicolon. That is because in C you just don't say print. Print is something you say with other languages like Python. In Python you just say print and it prints to the screen. In C you say printf, like this compiler says. It says implicit declaration of function print is invalid in C99. And then it says this error. Did you mean printf? And that's correct. I just meant printf. So the compiler is also very useful, and it tells me what's going on in my program. So let's try making main2 again. And now it's made it. So now I can run this program again to see what we get. And it says program to compute and output the perimeter and area of a rectangle. And notice that the terminal didn't go to the new line. That is because in C you also need to specify a \n at the end to make a new line character. If we run it again now, you will see it outputs perfectly. So now that we know how to print out to the screen, now we can just complete the rest of the program. So we say length equals 6.0. If you want to have less lines in your code, you should declare this at the beginning of length here. So we can say double length equals 6.0 and it will do the same. So we can just delete that code and nothing will go wrong. This basically just changes the variable here, because at the moment here in our program, width has some random number or maybe no value at all. Maybe it just contains 0.00 or maybe some other value. That's because we always declare our variables a default value to make sure the values are what we expect. You would want less lines of code in your program. That's why we're doing this. So perimeter here, you can also just you can cut this perimeter and define it there. What you want to use to plug in a variable is some code that looks similar to this. Notice that this isn't really what I want to use, so I'm just going to change it so that I can then tell you what this means. So first I'm just going to test out if this actually works. I say make main2, and I run main2, and it outputs 6.00, and that is the length here. So it outputs the length correctly. So you'll see I used this strange syntax into my printf. Now, even if you are somewhat experienced programmer, you won't really have to memorize the syntax for every language, because this syntax will vary from languages. C is a little bit tedious, I think, because other languages makes everything quite more easier and simplified, but C is also a great way to learn this type of syntax. So let's get down to it. So I said %f. What does %f mean? It means plug in a float. Now, we had this double values here, but we also could have made it float. What is the difference between a double and a float? A double contains a higher digit value, so it can store greater values, where a float doesn't have that power. But in this case, we are just writing a simple C and C++ program. We're not going to use massive amounts of digits. If you want to use big amounts of digits, I would recommend using a double instead of a float. But let's just keep it a float for a moment. So we say %f, which basically means plugging a variable of type float inside of this printf statement. Then we set \n, which just means new line character. We can really just get that out if that confuses anyone. So we say, let's just clear this. If we say make main2 and then just run this main2 program, we will see everything is now kind of cluttered up here. There's no new line here, but it still outputs the same. This $sign is just part of the terminal window. That's all why I said \n, and then we run it, and then we compile. We compile it and then we run it. Okay. So we say for C, plug in this float value or double value. Then we say comma length, which means this is the value that needs to be plugged in. And we can plug in multiple values, really. We can maybe say another %f here, and then we say we want the width maybe. And then if we run the program, we should see some results. Yes, so we're going to see 6 and 4, and you can see 6 and 4 above here is our length and width, which we just plugged into our printf statement. And you can experiment and play around with it in the CS50 sandbox if you want to. For now, we're just going to convert this program. So we say printf equals, and then we plug in our float value right here, and then we say comma length, which will plug in the length into this printf statement. We can really get rid of this right now. Next we have a space, and then length, and then inline, which just maybe it's just, you can just make a \n here to simulate that, and then width equals width. You can just maybe just copy this again. Instead of length, we're going to use width. Here we have perimeter. We can just really do the same here. And notice the C code is actually less than the C++ code. That's because C++ does a lot more actually than C does, but it accomplishes the same thing really. You can really just do that in C and not worry about anything. and here we have area. I mean, this really isn't that difficult. Now if we run this, I mean if we compile and run this program, we'll get some errors because I didn't make semicolons at the end. If you use a language like Python, you will notice you don't need semicolons, and then if you transition back to C or C++, then you suddenly forget your semicolons. And there we have our print statements correctly. And if you look at this version of the program and we run that, so if I run main2, you'll see this, but if I run main, I would see this. And notice the output is different because the way C and C++ outputs things are different. C out is different from C's printf statement, in that C++ does some more work with the C out, because if there was a decimal value, then C++ would have outputted it correctly, but if there isn't a 2 decimal value, then it will just output 6 and 4 and 184 and 24. So in that sense, C++ is a little bit better than C. And you may notice I am having a little bit of lag on CS50 Sandbox. That's because if you're having a terrible internet connection, or if your internet dips for a bit, then CS50 Sandbox will kind of slow down a bit. So if you're using a terrible internet connection, I have a solution for you. Read the docs on how to download CS50 IDE offline and setting it up using Docker. And it's really simple, just follow some instructions. It's for Linux, Macs and Windows, so you just use that. Now after we finished both these C++ and C programs, we are going to do a little variation to them to explain another concept, and that is keyboard input. To make a keyboard input in C++, you just say cin instead of cout, and you change these arrows to go the other way around. And because we're inputting something, you may have a little different syntax, because we are going to need to tell this where to store it actually. So how do we take user input? Well, we have to make some changes, like we need to output something to tell the person, please input length. Then the person can input the length by telling cin, which is the exact opposite of outputs. And then you can just type length here. That should work. So if we say make main, and then we run main, it says please input the length. Okay, I want 5 as the length. And it says length is 5, width is 4, and it calculated a new area. 5 times 4 is 20. And it also calculated the parameter. So that's the simple parts of C++ with input statements, but you can do the same with C programs as well. In our C program, if we want to do this, we can just say something like getInt, which is a pre-made function by CS50 that you can look into. You can just Google CS50 getInt to look at what the function actually is. But basically you can say please input length, and you should get the same results. So you say make main2, and then we run main2, and it says please input length. Okay, I'm using 5, and you will see, because we have a different values, you will see 6 times 4, which is 24, so that's correct. So that's your simple first C and C++ program. Now there's also this interesting part in C and C++, and this is called typecasting. Basically with typecasting you can change a variable's data type by just specifying in brackets what you want it to be. So in this case I can convert my double length into an integer length using just this brackets int, and then it should work, unless C++ is a bit different than C, and it compiles fine. So we can input the length, say 6.32, and we can see it outputted our length differently. It just cuts off this .32 at the end. So that's what typecasting does, is it rounds down. It basically throws away this decimal value at the end, and then you're just left with 6. But in this case, the perimeter area was calculated before we typecasted the length. So the perimeter area wasn't affected, but it showed the length as this weird thing now. But if we removed that, and we input something like 5.32, we will see that 5.32 gets displayed on the screen perfectly and nothing gets thrown away. So that's what typecasting does. And in C you just does the same. You just do the same. You just go in parentheses, int, and then it should work. And actually I messed up this get int right here, because actually this needs to be stored. So actually I needed to say length equals get int. So that's just a problem that I made. So notice what happened. It requested me another time, please input length right here. That's because the getInt function, it was made that you only can input an integer into this function. If you try to type in a decimal or float or double, it won't work. Sorry, pal. Okay, for the rest of this tutorial I'll be using my CS50 IDE offline. You can read up how it works just by googling CS50 IDE offline, and then there's just this helpful instructions how to set it up. It's really simple. You can also set up a batch file on your desktop that you can run every time just to run your IDE. So you will see in the right hand corner, you will see Docker desktop is running. When you see the Docker desktop is running, you will run this batch file and it will automatically start your IDE for you. And we'll just make our main.c here and our main.c++ here. And you can see this icons here just to indicate, this is a C and this is a C++. And actually this may not work, so just make let's just make the main.c main2 again like we did. So we have hashtag include iostream, and we have using namespace std, we have int main, int cal, burned in a day, int cal burned in a week, int day, and you may guess this program, all that it does is it calculates the number of calories you burn every day and in a week. So for this program, we just use a while statement. While the day is smaller or equal to 7, that's what the syntax says. So the program will execute this code while the day is smaller or equal to 7. So what it does, it says cout enter calories burned each day, and then input calculate calories burned in a day, cout end line, and then calculate the calories burned in a week, and then it says day equals day plus 1, and that's the interesting part, because here we can see day equals 1. So you can just think that here there is 1, and here there is 1, and here there is 1. But it's a variable, so this will become 2, then it will become 3, then it will become 4, then it will become 5, then it will become 6, and then it will become 7, and then it will just stop executing, because now the variable is 7 equals 7. So now the while loop will just stop executing. And that's why we need variables. But let's run this program. So how we open our terminal is we right click on our folder and we say open terminal here, which will open a terminal, and you can bring this terminal down below. Then you can just say make main, and it will run your C++ just like it did in the sandbox. Then you can just come look and see what the program does. Enter calories burned each day. Let's just say 500 because I feel muscular. Day 2 I felt lazy, so I didn't burn anything. Day 3 also. Day 4 I really pushed myself and burned 1,000 calories, and then 300, and then 200, and then I just do that. So the average number of calories burned each day is 300, and that's exactly what the program does. So now we will implement this in C. And it's not that difficult. And something I just noticed is our main didn't really end quite right. Unless, yeah, it did end right, it just didn't indent it correctly. So we'll just copy this into main.c, and then we'll just change this to, I think it's stdio.h, I'm not sure, and then we just get rid of this, and then we just say make main2, and it will give us errors because we didn't finish the program yet. We need to change this outputs to prints. So we say printf, and then we say enter calories burned each day. And actually you can just use getInt at this moment. Really, you're just making life hard for you. So just say day equals, or actually I'm making life hard for me because I'm doing the programming. So we just copy this, and then we just actually day is integer, so it says day 1, day 2, day 3, so we need to make some differences here. We can say plus, and then day, and then plus, and then this parentheses right here, ended with a semicolon. and that's the equal of this output statement. And actually you're inputting this, so you just get rid of that. And then let's see out's a \n. You don't have to worry about that with get int, I think. We'll worry about that later. And here we have average number of calories burned each day. And we need to change this. You can say calories burned in a week equals calories burned in a week divided by 7. And let's just simplify this, because we are copy and pasting in programming, and that's kind of wrong. So you can say equals divided, or divided equals, whatever works. I can't remember. We will see when we compile. And then we can just print the average number of calories burned each day. And then we can just input this calories burned in a week, and then we can just see if something works. It's reminding me I didn't save yet. And now we get some errors. And here is where we start to try and debug our code just by reading the errors from top to bottom. So it says use of undeclared identifier cout, and I don't think I have couts in my code. Oh, okay, because we don't. So it says implicit declaration of function get is invalid in C++, I mean in C99. What that basically means is I forgot that to include Cs50. That might be there some of the issues, but not all of them. So we are getting errors, and that's maybe because I didn't really follow the correct way of printing everything, because we needed to tell the compiler here that we needed to input an integer right here, and then we needed to say comma cal burn in a week. In C++, I may think that you can just say plus and inside of your statements, and it might just concatenate everything correctly. Maybe you needed to static cast everything to a string to make sure that it works. But in this case, we might have a little problem, but it's nothing to worry about. So we can tell the compiler here is an integer, and actually you can just maybe put this together and then just say the variable here, I think it was day, Then you can just compile it again. Maybe it will work now. Yes, success. So now it says enter calories burned for each. Okay, 50, 300, 500, 200, 100, and 500, and 200. And now it says calories burned each day, 264. I forgot an end line here. So I can just say \n here. It's supposed to work. And notice that the get int is actually making the \n statements for you, because we don't have a \n statement here. Now do we? So we can just type in some values here just to see if everything works, and we still have like a we don't have a \n here. Okay, something that you will use throughout your programming career in C and C++, if you use that on a daily basis, is a for loop. So a for loop looks like this. You say for int equals 0, I is smaller than 7, I++. And then you can just make this curly braces here. And then you can just put all of these values right here, and it's supposed to work. And the way you can indent your code is by using Shift Tab and Tab. It's quite simple. If you run this program, you will see I forgot something here, and that is die. So you have 500, 200, 300. You can continue testing this software and you can see it works perfectly. I just forgot to put the variable name here, which is important. So the structure of the for loop is for int I equals 0, I smaller than 7, I++. If you look at our C++, you can see how it differs from one another, but accomplishes the same task. And you can do the same with C++ just by replacing this text with this. Make main, and then run main. Here is the statement you would use in an array. Int num5 and then a semicolon. That will give you 5 elements that's stored inside of an array, a one-dimensional array. And you can access these elements by using num0, num1, num2, num3, and num4. Like in this example, like you can say num0 equals 15, num1 equals 25, num2 equals 30. And actually, let's try this out. So in my program, I'm just going to delete what we did earlier. And then we're going to make int nums, let's call it nums, and then we make it 5. Then we can say nums 0 equals 15, nums 1 equals 25, and I'm just going to copy this and then call this 2, 3, 4, and that's all our 5 elements. And notice that computer scientists start counting at 0. That's just for simplicity's sakes. So now we can say for int I equals 0, I smaller than 5, I plus plus. Then we can just say cout nums of I, and maybe just an end line to make sure. Then we can just say make main, and then we run main, and there we have our 5 elements of our array. And there's different ways you can assign values to an array. One other way you might have thought we could have done this is you could just say equals here, and then curly braces. You can just tell the compiler what the elements are. It's like 15, 25, 15, 25, 15, and that will give us our elements as well. So if we just compile this, you get your 5 elements like that also. And what would happen if you like miss an element? Let's just see that that element will just have a default value of 0. What if we add too much elements, like 30, and we just say we need to go 6? Now we get an error, too many initializers for int 5, which is great. So that's why it's important to only use the amount of elements you specify inside of your array. If you don't want to care about specifying, you can just make a empty braces like that, and it will automatically identify how many elements is inside of your array. And in C you just basically do the same, except we're just going to change the print statements. So we're going to say print f, and maybe we can just print nums I don't know. We have to see about that. I don't think so. I think I'm going to get an error. 2 times within 0 is kind of, well, it doesn't do anything. Yeah, I'm going to get an error, and that's because I need to like tell the compiler here's an integer, and then tell it where to find it. I need to run main too. Sorry about that. So there we go. As simple as that. And you can just say \n here. Then you get your list here. And notice I said list, and that's because in other languages like Python we use lists. If you look at Python lists, you will see in Python the array version in Python is lists. So you can just, if you want to go into Python, just know that lists is the same as arrays. Except it might be easier, because in Python you can like shrink and grow your arrays. In C, if you want to shrink and grow your arrays, you need to do something else, and that something else is called pointers and dynamic memory allocation. Okay, so let's look at something else that's interesting. This is called two-dimensional arrays, and basically it's like a normal array, but it's in 2 dimensions. You can think of a normal array as being like this rows, and in a 2-dimensional array you also get columns. How you would declare something like this is by just saying something like int array, and then you have it like this. How you would declare a two-dimensional array is by saying something like this: int array for free, and then you have something like this. It's quite simple, really. But your challenge for today is to go ahead and play around with two-dimensional arrays and make something constructive, like make a tic-tac-toe game through a two-dimensional array. That's your challenge for today. Let's look at functions. So first I'll be deleting some of our old code, and then we're going to look at functions. So with functions you get something like this. For a function that doesn't take any type, that just does something, you can make something like a void function, which means it returns nothing, it just does something. Let's make a function that does something. And then we just declare something like cout. Yay, I'm doing something. And then we can just say \n here, because we can. So now we can just go here and say does something, and that will do something. So now we can just go ahead and say make main, and then we can just say run main. Yay, I'm doing something. And then you can just maybe put this inside of a for loop, because you can do that. And let's make it I equals 0, I smaller than 50, and then I just say I plus plus. Then I can just put this function call right here. Because what I'm doing here is I'm calling this function, and then it outputs yay, I'm doing something. It's quite simple really. And there we go. Yay, I'm doing something, and it does it 50 times. Now let's go to more complicated functions that actually needs inputs, like maybe int get number, and then you go ahead and put in parentheses int number. But it can be anything. It can be x, it can be y, it can be number, it can be anything really. So basically what we're going to do is we're going to say cin get number I. And what the function actually needs to do, it's going to output the number maybe. I'm going, maybe just say I'm going to output a number called, and then we're going to just put in the number right here, and maybe an end line. But at the moment it's not really going to return a number or anything, it's just going to output something. And actually it's not going to output anything because something went wrong. And it might be because we actually just did something terrible here. So we're going to just say its number, and then we're going to say in number, and then we're going to say this actually can just be void still, because we're not really getting anything out of this function as of yet. So we're just going to say get number, and we're going to put in the number here. Then we can, it's not showing anything because we need to type in a number. So we're going to say 50. Yay, I'm going to output a number called 50. 20. Yay, I'm going to output a number called 20. And it's going to do it 50 times. If you want to stop the program, just press Ctrl C. That will stop your program. So let's actually get the number actually. So we're just going to say return the number, for simplicity's sakes. Get number. So we're going to see out that number maybe. Cannot convert get number type void to type const unsigned char. Well, let's just then store it into a number 2. And then we're just going to see out number 2. And we're going to say number 2 equals get number. Number 2 was not declared. Well, we didn't really declare it now, did we? So we're just going to say int number 2. Void value not ignored as it ought to be. Number 2 equals get number. Well, that's because we're returning a number now. It's no longer void. So let's change that to int now. So we say make main. Now we're just going to type in number 30. And you can see it kind of stacks up, right? Because it's actually outputting a number and it's not doing the end lines. We can't really see. So type in a number, get a number. Type in a number, get a number. That's how easy it is to get a number. And you may use get numbers and get functions throughout C++ when you go to object-oriented programming maybe, which we will cover later in this video. But that's how functions work. You don't really need to use functions. It's just there to, like, if you need to do a lot of things, then you can, and you do it repetitively, you may as well just use a function. Like if you're going to do something 5 times or 10 times or 50 times, you can just make a function to do that for you, right? You don't really need to do that 50 times inside of your main function. You can do this inside of our function, and that's the whole point of functions. I'm just demonstrating how a function works and by doing error checking and changing things as we go. But let's go on to something else. Something else we were going to talk about is debugging. Now the CS50 IDE comes with a debugger for your C code, but I can't seem to get it to work with C++. I might be doing something wrong. You can maybe read up on it if you want. But how debugging works is you first need to compile your program normally. And what debugging does is it looks for logical errors in your code, like if a value comes differently than you expect, or something is going wrong with your program. It compiles fine, but you don't really know what's going on. So you can say debug 50 main2, and then it will open up this debugger, and you can click on this on any line here to make breakpoints, which basically will tell the program to break at that moment. And now we get this menu right here. So we can say step over, which will then print 50, and then you can step over return 0, which will end your program. Now you may think this is very useful, and it is really. If you have a program that's very complicated, just use debugging to fix the problem. Now we're going to dive into pointers and dynamic arrays. An array created during the execution of a program is called a dynamic array. To create a dynamic array, we use the second form of the new operator. The statement int star p declares p to be the pointer variable of a type int. The statement p equals new int 10 allocates 10 contiguous memory locations, each of type int, and stores the address of the first memory location into p. In other words, the operator new creates an array of 10 components of type int. It returns the base address of the array, and the assignment operator stores the base address of the array into p. Thus, the statement star p equals 25 stores 25 into the first memory location, and the statements p++ semicolon, p points to the next array component, star p equals 35 stores 35 into the second memory location. Thus, by using the increment and decrement operations, you can access the components of the array. Of course, after performing a few increment operations, it is possible to lose track of the first array component. C++ allows us to use array notations to access these memory locations. For example, the statements p0 equals 25, p1 equals 35, store 25 and 35 into the first and second array components, respectively. That is, p0 refers to the first array component, p1 refers to the second array component, and so on. The following for loop initializes each array component to 0, in which j is an int variable. When the array notation is used to process the array pointed to by p, p stays fixed at the first memory location. Moreover, p is a dynamic array created during program execution. If you want to dynamically allocate a pointer in C, you just use malloc. So you can declare a dynamic pointer. So you just say p malloc size of, and then you can just say how big your pointer must be. In C, it's easy to allocate memory for pointers. All that you say is int star p equals malloc size of 5, and that will give you 5 integers. And then after you use that, you just say free p, and that will just free that memory for you. But your challenge is to make a pointer dynamically in C++ and then free it. If you want to compare a string in C++, you would just say string 1 equal to string 2. But in C, you need to say string compare. Otherwise it wouldn't work. We can test that out if you want. So here it says string compare compares two strings, string 1 and string 2. And return a value, string compare will return 0 if the two strings are equal, smaller than 0 if string 1 comes before string 2 alphabetically, and greater than 0 if string 1 comes after string 2 alphabetically. And that's just the way it's defined. And here's some example usage. And now we have an else statement that if the strings are different. So if they are equal to 0, print the same. If they are not, print different, and then return 0 after the program is done. So if we say make main2, we will get some errors because all that I actually did was included this code using okay, that's all that was wrong. So now we can run it. Okay, let's type in cat, dog, they are different. Let's type in cat, cat, they are the same. And as you can see, if I maybe don't type anything, it'll say same. If I don't print anything there, different. Okay, quite interesting. And you can also debug your code if you want, if you struggle with anything. At the moment I am quite satisfied with this code, so now I'm going to try and string compare in C++. So I'm going to delete this code here. I'm just going to copy this code and make some modifications with the string compare, like S and T needs to be compared, right? So if S is equal to T, then it's same. I'm just testing out. Okay, it's moaning about printf, so I'm just going to say cout same with a backslash in. Same goes here. I'm just actually going to copy this and just change it to different. Delete that code right there, and then we can just make main. Okay, getString was not declared in the scope because getString is a CS50 C function, which means that we probably shouldn't use it in C++. Otherwise we might get weird issues. You can maybe test it out yourself and see if it works, but I'm just going to say C in. I'm going to get something like this. Dereference the pointer to insert it there. And we can maybe make a cout statement here, just to say is, and then in that. We are still probably going to get errors, but I just want to see if that error is resolved. Expected initializer before cout. This is quite interesting. So it's saying it needs an initializer before cout. What you can do is you can also Google. You also must include string if you want to use string. Maybe that's the problem. So you can maybe include it here at the top. No, that's not the issue. Quite interesting. Why am I getting this error now? Oh, there's a semicolon there. Missing. Okay, so finally we have some code that's working. So what we need to do is just do the same for T. So we can basically just copy this code right here, and just replace S with D. It's quite dirty approach, but it always works if you don't want to struggle doing things. You can also maybe make a function to do some of this work, but I don't know if that's really necessary. Okay, let's run make. Okay. So it's asking for string, that's a cat segmentation fault. Okay. So we started working with strings and we already got our first segmentation fault. It isn't really strings, it's pointers. First time we worked with pointers and we are getting a segmentation fault. So what would be nice is to use a debugger, but since C++ debugger doesn't really work as well, we may just use normal cout statements to find out where our code is breaking. So let us print out actually I think the code may be buggy here maybe. So I'm just going to print out this. It's still going to give a segmentation fault, but at least we can maybe see what's going on. So what's happening here? Okay, it printed out a C, right? It's very important to maybe figure out where the program is breaking. And it braked before we could even type in here T. So it's definitely something here that's not right, maybe. What if we just print out S? What will that give us? Huh. It's kind of interesting. Maybe it's the CN, because maybe it's trying to do something with the pointer and not the text itself. So maybe we can just create another char that's maybe just S for string, and we can maybe just say S here just to prove a point. I know something is definitely strange. You can also comment out some code if you want to. So now it's oh, you know what? Maybe you just need to call this stir one. Okay. So some interesting things that's going on. We didn't even type in here a T to get another string, but somehow we did. So that's the first issue. And the second issue is I think we may be not storing the values correctly. So it is quite interesting to do this in C++, even for me, because I didn't do something like this in C. I mean, I did this in C but not in C++. I mean, in C it's quite interesting. You get a string. Actually, we maybe can try to use this getString function to maybe see if it will work in C++. But I doubt really strongly. So instead of just using the cin and cout methods, we can maybe just say something like this. And we can just say get a string. So now we're going to test out a function that I don't know if it will work. Yes, it says undefined reference to getString, even though I imported cs50.h, and that's because cs50.h is a library for C and not for C++. So maybe we can just Google cin.get maybe. So char string 100 cin string. So what they are doing here is they're declaring a string of a fixed length, and we are not doing that. We are just saying string 1, and that's why maybe it's only one character instead of the length of the actual input. Okay, so string cout into string get line. So maybe you need to use this getLine function because it's strings. I remember something around this in C++ back in the time I used it. So we're just going to use a normal getLine function. And I'm just going to get rid of T for the moment, just so we can just test our code out. T was not declared. Okay, let's just do T, but we're going to call it string 1 and string 2 now, not S and T anymore. Doesn't really make a difference. We can just say string 1 is equal to string 2, and we'll output something. And I missed a semicolon, maybe line. This is quite interesting. I just get rid of this unnecessary imports. Are we still using getString somewhere? Nope. We still have this getNumber function. The nice thing about functions is you can just use it in any program and it won't affect it at all. And it will spare you some time with coding. You know, we need to test this segment for segment It doesn't make sense to try and run everything at once. So strings to semicolon. Actually just do that. No problems. So obviously we can enter strings. So now we're going to go to this getLine function. Okay, so we're not getting any problems. So I don't really know. Maybe it was just a tiny little glitch or something. Maybe I forgot to compile my code. But you can see it works. I maybe just forgot to compile the code, maybe, or something. So, as you can see in C++, it's very easy to compare strings. You can just say string 1 string is equal to string 2. In C, you need to use string compare and then s and t as a parameter, and then you must say equal to 0 for equality. And that's how you compare strings in C++ and C. Now, here we used pointers, and here we didn't. All as we did was we declared strings, but a string is just an array of characters, or a character pointer to the first. So with other words, it's a pointer to the first character inside of the string. That's what we can see here. We declared a pointer to the first character of the word or string, and it is always structured to contain the entire string, no matter what. But in C++, you don't really need to use pointers for this example, and also in C you can just use strings. You don't need to use pointers, but this is just a normal pointer example and one without pointers. So as you can see, it's actually both the same. But what we want to do is maybe re-implement the C++ program to use pointers instead of strings, even though it's the same thing. So I'm just going to say character pointer maybe, and you can keep the spacing like this, or even this, whatever is the most appropriate for you to use. So we're just using jar pointer, and we can just look at how it's maybe implemented. I don't know really. We can maybe just run it and just see some errors. It's complaining about this getLine function because it's actually supposed to take in a string, not just a pointer. So that may be what the problem is. But you can take it upon yourself to maybe re-implement this program with pointers. Okay, we're going to look at some recursive functions briefly, just to give you an idea of what it is. Now what do I mean about recursive functions? This involves the process of solving a problem by reducing it to smaller versions of itself. Recursion is a very powerful way to solve certain problems for which the solution would otherwise be complicated. We are going to look at a factorial function which has a recursive definition. So in our main program we have this factorial function right here where we can say if num equals 0 then return 1, else return num times the factorial of num minus 1. This is a very recursive definition to get a factorial of a number. There might be other ways to implement it, but notice we didn't use any braces here like this. We didn't use braces, and that's one thing about C++ is you don't have to use braces. My understanding and experience of C is that you almost always need braces, but in C++ you don't have to make braces when you don't need to. It's sometimes just a waste of lines. So let's just check out this function. So in our main we're going to say cout factorial of 3 and then end line and then return 0. So let's just go ahead and make main, and then we're going to run main. Here we can see 6, which is quite nice. If we look at a factorial function, it takes in a number and it returns a number. So always this variable here or data type here is always the return type. So it returns something right here. It returns this here, and it will be returned here. Also, it takes as a parameter an integer, but it could have been a float or maybe even a string, and then convert that string to a number. Basically, you can do something like that if you know a bit of ASCII. You can Google a bit about ASCII if you want to know more about that. Essentially, in ASCII, every character has a different value. Like, let's just test that out right now. So if we say cout and we say the integer value of a, and I don't know if this is going to work. I really don't know. But you can see the ASCII value of a is 97. Essentially, they made a value for your keyboard, and every single key on your keyboard has a specific value. And you can actually compare characters like this. Like you can say, if you look at B, you can maybe see the difference between A and B. You can see that B is greater than A, and if we look at the capitalization of A and B, you will also see it's quite different. Like it's 65 and 66, which is quite interesting. Nevertheless, this was a tutorial about recursive functions, and I also mixed it a bit with ASCIIs. Something else you can do is like I said, you can say if B, the character B, is greater than the character A, which we in fact know it is, then cout you compared A and B, and B is greater than A, with a backslash in maybe, and a semicolon. So we say make main, then we can see you compared A and B is greater than A. So that's just some simple way of comparing characters. You can actually substitute these with their actual ASCII values. Like I think it was 97 and 98, so you can just separate it with that, just to like wrap your mind around it. I think it must be 98. It's greater than 97. So you say make main, and then you just, you get the same value. I just replace the character's ASCII value with its integer value. Okay, so the next thing we're going to look out for is structs. Structs is just like a collection of data that you can store, like in a box. Like you can store multiple characters and integers inside of a box, if that makes sense, and that box is called a struct. Now here I made something called struct character, which is just going to store a character and a character pointer. Now we can ignore the pointer for now, but we can definitely see that we can store some sort of pointer inside of the struct, and then we can also store an actual character. This might be useful later on in a future tutorial. So basically, if you want to declare a struct, you can say type def struct character, and then struct character pointer next character ch semicolon character semicolon. Then in your main program you can say something like character A, and then you can say a.ch is the character A, and then cout print the character A. But maybe I just needed to say something like this, maybe just to make sure it works. So we can say make main and then run it, and then we can see the character A is printed to the screen. Let's just change this up a bit, just so it's a bit more clear. I can say int number. You can maybe store a table or something. You can store anything if you want. Let me call this a fruit for now, and then call this int quantity to say how much fruit is inside of the structure, and then string type to store the type of fruit. So now we can say fruit A, but you can maybe call it X. Let's just call it fruit X. And then inside fruit X we can say x dot quantity equals 15, x dot type equals banana, and then you can see out this type of values. You can see out this, and you can see out the type very easily. And we're just going to run it. You can see it printed out 15 and banana. So it's just a way of data encapsulation, as you can think, and it may be useful to store multiple things at once. I know we did this in C++, but this is actually how you would do everything in C. In C++, you have something called classes, which we can dive into later, just for a bit. But C++ uses classes instead of maybe structs. It can use structs also. I prefer structs because it's easier for me to understand. But C++ is very flexible when it comes with its version of structs, which is classes. You can think of structs and classes as basically the same thing almost, but classes have more features than structs. Like in classes you can store functions, constructors, destructors, and all sorts of things. And in something like C, you don't have that ability. You only have to use structs in C. That is why you preferably want to use C++ over C. But if I had to make a program in C or C++, I probably stick with C instead. except when I needed to need to compare strings or some sort of things like that. Something like that C++ can do that C can't, then I will use C++. The most complicated thing I'm going to talk about briefly is something called a linked list. Now you can see I gave some sort of definition here on the right hand side and some images so that you maybe can understand how it works better, and you can pause the video to maybe read through it if you want. But essentially I made my own type of linked list that you can just fool around with and see how it works. You might get some segmentation faults on the way, but this will be great practice for you if you want to maybe learn more in C and C++. It will be a great challenge for you to maybe make your own linked list with your own data types. And you can see I used the struct that I first showed you when I introduced structs to you. And here I made my own function to free a linked list, and here I just made some code using the linked list. I don't know if everything is functional, I haven't tested it, but you can fool around with it and maybe see how it works. Maybe Google how to make your own linked list and learn things from there. You could maybe look at CS50's video on linked lists. They also explain it very good. But essentially you can read this definition. I will give my code to you so that you can work with it and experiment with it, and yeah, that's all. Basically with linked lists you just have a structure here, and then you declare your structure here, and in this case it's a pointer to a structure. And here you can see I allocated some memory for the structure. Then I created some while loop to say while the next pointer isn't null, change the values. And here I just printed it to make sure everything is fine, and then here I freed it. The code I have tested it out. It may give you a segmentation fault, but the main purpose is that you can use this code to start with your linked list. It may help you, it may not help you. The best is to do everything yourself, but in this case I gave you guys a starting point. This code isn't buggy, but maybe the way I initialized my linked list was a bit deliberately bugged from the beginning, because I just allocated memory and made it nothing. So my opinion is try this out yourself, experiment with it, see if you can understand, see if you can see how you can maybe input these values inside of your linked list, and see what happens when you don't, and when everything is just null. See how many segmentation faults you can get, and enjoy programming in C. This is just a C implementation of a linked list. I know C++ must have a different way of implementing it, but we didn't pay much attention to C throughout this video, and I just wanted to give some recognition to C with this last linked list example. So now we're going to jump into the last section of this tutorial, which is object-oriented programming, or OOP. And that is something that C++ has, which C doesn't. What it exactly is you can make these types of classes inside of C++. Here you can see I made a class rectangle type. And as I stated, a class is just like a struct. It just has extra things like functions inside of it. Like here you can see it has set dimension, get length, get width, area, perimeter, and it has something called public and something called private. Public is everything that can be accessed by the user or whoever has the class. anybody that has access to the class, whether it is a library or library .h library. The public is for everybody to see. And the private is something people cannot directly access, so people cannot really directly access the length or width. They need to use the get length and get width functions to access those values. And if they wanted to set their values, they can use something called a constructor, and that is something that you will see I used right here in my main function. I used rectangle type rect, where I made an object from the class. An object is something that's created from a class. You can think of it as an instance of a class, basically. So here I made an object called rect of rectangle type, and in parentheses I said 50 and 40, which just specifies the length and width of the object. And that is part of the constructor, as you can think. And further, you can see I made a lot of different functions, like what does get length return, what does get width return. It's quite really simple. And I'm just made a normal main function where I just use this class to make an object and then just show you guys. So here I just outputted length of the rectangle, and I just said rect.getLength and then inline. And see out width, rect.width. Notice I didn't say length and width because I cannot access those values directly. It's private to me. I don't have access to it, but I do have access to the public functions like getWidth, getLength, and constructors like rectangle type. Here's the constructor for that. And then I just return 0. So it's a very simple program. And if I say make main dot main, you will see I returned the length and width of the object. So you can basically think of classes as like the blueprint of how your object is going to look. And the object itself is made from that blueprint. So a class is like a blueprint. You can think of it like a struct that has functions inside of it, like public and private and functions, and you can just think of a lot of things you can do with this. You can do things like inheritance and a lot of it. I'll be giving this code also in this description so that you can have a look at it and maybe just inspire yourself to object-oriented programming. Thank you guys for watching my video. I hope this helped you a lot. I will be posting videos of CS50's versions of pointers and also their version of linked lists. I'll also be posting a solution for the linked list. So after you tried to make your own linked list, you can look at my solution and see if it's anywhere near yours. I'll be posting the code for this object-oriented programming class so that you can have a look at it and maybe play around with it and just familiarize yourself with object-oriented programming. I just want to say thank you for watching my video, and I hope this helped you a lot.